There are a few places where specific events need to, in the quantum channel, need to be very specific, very precisely timed. So one example that I gave in one of the earlier slides is that two nodes each generate a photon, and they travel on optical fiber towards a device in the middle, which is called the Bell State Analyzer. And they need to interfere with each other. And it's a quantum process that only happens if the photons arrive exactly at the same time, so that the light pulses overlap exactly with each other when they arrive at that station. Now, how big a light pulse is depends on its bandwidth, but typically a pulse of a photon is about 1 nanosecond wide. If they arrive at exactly the same nanosecond or a few hundred picoseconds, then this effect that we need, this interference, happens. If one photon arrives a little bit too early or one arrives a little bit too late, then the quantum effect that we need to make the quantum network work doesn't happen. And so the clocks at each of the nodes that sent the original photon must run very precisely and must be very exactly synchronized so that those photons arrive at the desired time. There's other examples that I can give, but that's a typical example of why it's needed. And 1 nanosecond is a typical number. It's not as always, it's not a hard and black and white number. If it gets a little bit longer than that, the quality of the entanglements that are generated just get worse and worse. And once you get to a few nanoseconds, it becomes almost useless.